Good morning to everyone. In the last class, we discussed about the theory of plate tectonics. Okay, so that was covered in the last class, and the notes of which are also being provided. Okay, so today we'll be moving towards the seismic waves. Okay, and then we'll be studying on the types of seismic waves and little bit details the characteristics of those waves. Okay, so basically, what are seismic waves? Okay, so without any delay, I'm starting this lecture. So what are seismic waves? See, when there is, I think by now you know how this what is elastic rebound theory. Okay, so what happens the because of movement of tectonic plates. Okay, there is pressure developed inside the Earth's surface. Okay, generally the rocks. Okay, in the rocks the pressure develops. Okay, and this pressure continues to develop. Okay, and the rock continues to deform, but as they are deforming, the rock wants to move back to its original position and shape. Okay, but since there is continuous stress develop, so it starts getting deformed, and slowly what happens is a time comes when this energy or this stress that is being stored in the rocks, okay, they are released suddenly. Okay, because the rock is not able to handle any more deformation, so it deforms. Okay, sorry, it releases the energy. Okay, so this energy that is released, okay, causes your earthquake. All right, the energy that is released causes your earthquake. So once this energy is released, okay, so what happens then? This energy travels throughout the body and the surface of the earth in the form of seismic waves. Okay, so these waves we call these vibrations and energy that is moving throughout the body of the earth and on the surface of the earth. So these waves are your seismic waves. Okay, so there are basically two main types of seismic waves. Okay, so one is your body wave and one is your surface wave. Okay, so if you understand this, so there are two types of your seismic waves. Okay, one is body wave and the next is your surface wave. Okay, so by the name I think you are able to I think you are able to get some information little bit. Okay, body waves means there's something they have to relate something to the body of the earth, and surface waves means they have some relation with the surface of the earth, right? So what is actually body wave? Okay, so they travel body waves they travel through the body of the earth, so that is what they are differing, they are having difference with the surface waves. Okay, so they travel through the body of the earth, travel through the body of the earth. Okay, and surface waves, okay, by the word surface you may be able to understand. Okay, so they propagate along the surface of the earth. So propagate propagate along the surface of the earth. Okay, and there are some other characteristics that they are responsible for the collapse of the building. Okay, so have much higher amplitude. So surface waves have much higher amplitude and are responsible. So whenever a building is collapsing, so that collapse is because of the surface wave and not body wave. Why? Because surface waves travel through the surface, and your buildings and the structures are present in the on the surface of the earth. Okay, so hence the surface waves are responsible for collapse of building. Okay, so they are responsible for building collapse. Okay, for building collapse. Okay, Alright, so I think you are able to understand what's the surface wave and what is the body wave. So it is also written here, body waves can travel through the earth's inner layers, but surface waves can only move along the surface, okay, of planets like ripples on water, so radiate seismic energy as both body, okay. So alright, so we are moving to the next. Now there are different types, okay. So body wave, there are two types of body wave, okay. One is primary wave and one is secondary wave, and similarly in surface wave also you have two different types of surface wave. One is love wave and one is Rayleigh wave, okay. So we will be studying those, okay, in the next slides, okay. So moving to the next slide. So let's start with your primary wave, okay. So body wave, okay. So we are starting with your primary wave, or you can call it as P wave, okay. So basic characteristics of P wave, okay. So it is a body wave, travels through the body of the earth, okay. Also you remember this is the fastest moving wave, okay. So whenever there is a earthquake, you will observe that through seismograph readings, you will observe that primary wave or P wave travels, the first wave that you will observe is the primary wave, okay, because they move at a very high speed, okay. So fastest moving wave, and hence they arrive also first, okay, hence arrive first, okay. Since they move at a very high velocity, so they will also be able to detect the first, okay. And can travel through, they can travel through solid and liquid, okay. Travel through solids, liquids, okay, and sometimes air also, okay. All right, and also this velocity, okay. So they, since they are the fastest moving wave, but they are not always traveling with the same velocity in the different materials, okay. So the velocity of them, okay, the velocity ranges as per the material of the as per the state of the material, okay. That means for crust, okay, see if they are moving in crust, velocity is 5 to 7 kilometer per second, okay. So if they are in mantle and core, their velocity is 8 kilometer per second, okay. Their velocity is 8 kilometer per second, okay, if they are moving in the mantle and core, okay. And let's say they are moving in water, okay. So this type of wave can move in water also, okay. So in water they travel with a velocity of 1.5 kilometer per second, and air also they can move. So in air it is 0.3 kilometer per second. So whenever you're in an earthquake, whenever your windows are shattering, okay, so you can those are because of your primary waves, okay. So they can travel in any medium, okay. And also animals can hear, okay. So since these are the first type of wave that they can travel, okay, and they travel a lot before the earthquake has even started to originate, okay. So what happens, they start appearing, they start traveling a lot before, because see, since they are moving at a very high rate, okay, till the other waves arrive, they have already propagated through the body of the earth, okay. So hence this type of waves can be heard by the animals, okay. They can be easily detected and felt by the animals, okay. Alright, so I'll just show you how the movement of your p wave is. Okay, all right. So you see this particle. Okay, see this blackened out particle. Okay, and observe its movement. Okay, observe its movement. So this is the propagation of a p wave. Okay, how a p wave travels. Okay, it is a compressional movement. Okay, it is a compressional wave, just remember this. So p wave is a compressional, so it is looking as if something is being compressed. Okay, look at this black square, black particle, these are all particles, so it is being compressed, right? So this black, whenever the wave travels via that black square, okay, so it will, you will see that it is being compressed, right? Yes, so this is a compressional wave. Okay, so this is the movement of a p wave. All right, so I hope it is clear. So let's move to the next s wave. Okay, next is your secondary wave. So next is your secondary wave or s wave. Okay, so it's a body wave, obviously body wave. They cannot travel through liquids. Okay, cannot travel through liquids and air. So that means this type of waves cannot travel through rivers through rivers and oceans. Okay, so no water body. Okay, so they cannot travel through water body. Okay, and they arrive after p wave. Okay, arrive after p wave. Okay, and regarding their velocity, so again in crust, okay, so they travel at a velocity of 3 to 4 kilometer per second. Okay, it's slower than the p wave. Okay, so p wave is the fastest. All right, so in mantle they travel at a velocity of 4.5 kilometer per second, and in inner core they travel at your 2.5 to 3 kilometer per second. See, I have not written here outer core, inner cores. See, now one important note I am telling you, please note it down. See, the secondary wave cannot travel in liquids, right? So secondary wave cannot travel in liquids, so your outer core is liquid form. Okay, so there is liquid form in the outer core. So hence what happens is that this is one of the characteristic of your the scientists, the seismologists have noticed that. Okay, they have concluded that, okay, that since s waves cannot travel, okay, they cannot travel through liquid, hence the earth's outer core is a liquid, because they have not found any seismic data, okay, traveling to that. Okay, so since they can only move through solid rock and not through liquid medium, okay, so this property of s wave has led to a conclusion by the seismologists that the earth's outer core is liquid. Okay, so you can note that down. Okay, that's important information. All right. Okay, so we'll go to the this animation, okay, regarding how the movement of s wave is. Okay, so s means it will be in the shape of an s. Okay, so let's go to the movement. Okay, so you focus on the black dot. Okay, it's a black square. Okay, and then you will be able to understand. You can see the particle motion. Okay, so it is going this. Okay, so you see yes, so particle is moving up and down. You see the black particle. Okay, observe the black square, focus on the black square. It is one is going up and then is coming down, right? Okay, so hence the particle is moving up and down like the arrows that is mentioned with green color. Okay, just look at the particle, that black colored dot. Okay, okay, so this is the way how the S waves propagate. Okay, so moving to the next. Okay, so that is, now we will be studying the your surface waves. Okay, so under surface wave, so here it is surface wave. So under surface wave, we'll start with the love wave. Okay, so love wave, so it is named after, love wave is named after British mathematician. Okay, aeh love. Okay, a British mathematician. So you note these informations. Okay, you can write this in your disaster management register. Okay, so and this information I am providing, some information I may not write here, so that I'm speaking to you, so you can write it down. Okay, note it down, important information. So it is named after a British mathematician called as named as A.H. Love. Okay, because he worked on the mathematical model for this kind of wave. Okay, in 1911. Okay, so the British mathematician A.H. Love, he worked on mathematical modeling for this kind of wave. Okay, so he went for modeling of this kind of wave. Okay, in the year 1911. Okay, so hence it is named as love wave. Okay, as a tribute to him. Okay, so next is that this type of wave, they are the fastest moving surface wave. Okay, so fastest moving, you see this word fastest moving, so they are not the fastest moving wave. Okay, fastest moving wave is your primary wave, P wave. Okay, so they are the fastest moving surface wave. Okay, fastest moving surface wave. All right, also they produces horizontal motion. Okay, so produces horizontal motion. Okay, and since they are surface waves, so you will only find movement of this wave can only be produced on the surface of the earth. So it will only be at the surface of the earth, no crust, sorry, no mantle, no core. Okay, so they cannot travel to the body, so hence their velocity on the surface, okay, velocity on the surface of the earth is 2 to 4 kilometer per second. Okay, but then this depends on the propagation. Okay, the way it is being propagated. Okay, so generally it is, this is a general value. Okay, general value. Okay, all right. So I'll again show you the animation regarding this. So 2 to 4.5 kilometer per second. Okay, and it depends on the frequency of propagating wave. Okay, so this value depends on the frequency of the propagating wave. Okay, all right. So we go to the animation. You see the black dot. Okay, see the black dot and particle motion. Okay, so this is the motion of the particle. How you will observe this motion? You observe the black dot. Okay, so I'll play the video, so you can see the motion is, okay, see, observe the black dot and see these arrows that is marked with violet color. Okay, so you'll be able to observe how the particle is moving. So it is moving according to the direction of the arrows that is shown. Okay, so this side it is traveling and then back to this side it is traveling. Okay, see the black dot, it will be clear. Okay, and you can see these arrows also. Okay, okay, I hope this is clear. Okay, so we'll move to the next wave, that is your Rayleigh wave. Okay, all right. So moving to the last wave, that is your Rayleigh wave. Okay, Rayleigh wave, it's a surface wave. Okay, it's a surface wave. Okay, so rolls along the surface. So what is the some characteristics I'm writing? So how is the some characteristics of this wave I am writing? So there is rolling action. Okay, so this type of waves rolls along the surface. Okay, rolls along the surface like flow of like flow of river. Okay, rolls along the surface like flow of rivers. And then your the ground shaking. Okay, so most of the shaking in an earthquake is because of this Rayleigh wave. Okay, so that is very important. So most of the shaking in an earthquake is because of Rayleigh wave. Okay, so that is very important to remember. Okay, and the velocity okay is your 2 to 4.5 kilometer per second, and that depends on the this frequency of propagating wave. Okay, so it depends on the frequency of the propagating wave. Okay, all right. So just show you the animation. Okay, so how it looks. See this arrows. Okay, see the arrows again. See the arrows, how arrows are moving, and see this particle. Okay, dot. All right, so you'll understand how is the movement. So it is rolling. Okay, so there is a rolling action. Okay, so it is moving like this. Okay, okay, so there is a rolling action. Okay, so this is moving. Okay, okay, so I hope you have understood today's lecture. Okay, so if you have any doubts regarding this your regarding anything regarding your uh, seismic wave, you can obviously contact me. Okay, and you can ask your doubts. Okay, so some points I may not be writing on the presentation, so that I am speaking. Okay, so you note it down and you have to write these things in your register. Okay, so with that, thank you and have a great day.